In this video, I would like to talk a little bit more about methods. So, methods are functions that are created inside of a class. And they, of course, allow you to organize your programming statements, just like any function does. The programming statements now will have a name, so basically you end up with a named group of statements. And the toString method is the one that we've been working with. And certainly extracting data from a class using something like toString is pretty common. So much so that Python actually has a built-in method that does that for you. It's a little hidden one, kind of like the constructor is, called __str. And this would allow you to go ahead and extract data out. Let me see if I can show you an example. So here we have the test class I've been using, and let's see what's in there. We've got our first name, and we've got the getter and setter and toString method. Now what I want to do is I want to let's go ahead and take off my call to toString, and I'll run it just with the name of the object. And you can see that it prints out something. It prints out that there is a person object running out of the main script at address location 0x028, whatever. This is basically the address that I've been talking about when I go through and say, okay, imagine if you would that you've made an object and it's at address 46 or whatever. That's because I'm too lazy to give like a hexadecimal number to identify its location. But what Python does is that by default there's this built-in toString method that you don't see, but you inherit from the original object basic class or basic template class. So if you want to, you can actually go through and add in your own version. And then put in your own code. Is that indented correctly? Yeah, I probably should do it like this. Okay. And so now instead of doing the default behavior, it's going to use a different behavior. Actually, this different behavior didn't work so well, did it now? Let's see, why not? What did I mess up? Object 2, first name Sue. Oh, that's because I was messing with this, trying to show how you couldn't actually set the first person's name. There we go. Much better. Now this is calling the public property and setting Sue's first name. So now you can see that it's printing out that data. In fact, I'll just prove that's doing that. You can see that it runs the hidden invisible one if you just put out the name of the object. Now, we've been seeing this kind of behavior. Think of it this way. List item, I don't know, object 1. We know how to make a list. A couple square brackets, and you put some values in. I think my typing is really bad today. Worse than usual, that is. Okay, and now if you print the list, what happens? Well, turns out the list is made from a class. It will automatically create an object from you from the list class. And when it does, it has a toString method, or should I say underscore underscore string method. When you put in the name of the list object, it goes ahead and prints it out because the people that made the list class formatted the string extracting the data to look like this. That was their choice, and that's why whenever you just go ahead and put in a list or a tuple, which is a different class, you get a different result because their little method the toString method, or underscore underscore string method, is different on the tuple versus the list. Somebody designed it that way. Now when you make your own classes, you can go ahead and add your own version, and then you can have it do something, well, like this, although I'm not so sure that that's going to be all that useful. Anyway, what happens is that you're overriding the original. You're overriding the built-in one.
New message from Bill Fletcher.
And you're overriding the original one. So what's happening is that when you call toString, you explicitly go ahead and call the toString method. But when you do this, it implicitly and visibly automatically calls the string method. You can see here in my code I'm returning the same thing. In fact, probably a better way to do it is to do this. Just call toString. The reason for that is that way if you ever need to update your code, you can update it once and it will work for both the explicit version and the implicit version. Now any changes I make here will automatically apply to the implicit version underscore underscore str underscore underscore, or as I like to call it, the toString method, because that's what it does. It converts something to string. Now, there actually are a lot of built-in little methods that come with the basic starting template object, starting class object. Another one of these is the class. And this one's actually kind of handy because I can go through and say, okay, what type of class is this? And because I use parentheses, it tells me it's a tuple. Versus when we used square brackets, it will tell me it's a list. And again, that's because somebody overrode the underscore underscore class method that is part of, implicitly part of the list object. They just went ahead and made it format to look like that. That was their choice. As you saw when I hit the dot, there was actually quite a lot of different things that I could do, including some of these like class, string, add, contains, delete an attribute, delete an item, a whole bunch. There's also another one you're going to hear about. It's called the destructor. Now the constructor is used whenever you create a brand new object. The destructor is used whenever you go through and destroy an object. Now the objects in Python are destroyed or destructed when they eventually time out. In other words, you use a you will create an object like obj p2 to a person. And on Python's runtime, it goes through and creates a little object in memory. Creates a little object in memory in the runtime. Now, as soon as you run this line of code, the constructor fires off and it does whatever is in the constructor code. However, when the script finishes running, it actually gets rid of that line. There's no longer a connection to that object, but that object may still be out in the Python runtime, and eventually it will be cleaned up. Python, like many languages, has a garbage collector that goes through scanning through the memory for any objects that are floating around in memory but do not have a reference back to a variable. And when it finds one of these, it just cleans them up. It just gets rid of them. When it goes ahead and gets rid of that object, the code in the destructor, which for all intents and purposes would be here, will run. Anyway, destructor is kind of an advanced feature. That's not something we really are going to use or care about. They need to be used with care. There's a number of things going on there. So all you really need to know is that destructors are used to do cleanup code. So you would make a method look like this, and then you would go through and add any code that would clean up things such as, oh, I don't know, maybe closing connections to a database, or deleting files that were on the drive, or whatever it would be. You've kind of seen this behavior where a lot of times when you go through and make a brand new file to open up a connection to a text file, you later on close it. And in doing so, it actually goes through and runs some cleanup code and flushes the data from memory into the text file. But if you were to leave that open, the destructor could automatically do that for you. In fact, if you use the using statement when you go through and open your connection, as soon as it loses scope, the variable that is your file handle loses scope, it kicks off the destruction of the object, running the destructor and allowing it to close. So this is one of the reasons why you don't need close when you use the using statement. Again, this is an advanced feature. I wouldn't worry about it too much. For the reading, you just need to know that it exists. Another thing about methods you should know about is the concept of a static method. Now, we looked at this before. A static method, like in a math class, and that's what we used last time too, I go through and make it add. Notice that there's no word self. I don't have the word self. And that's because a static method, I'm not using an object instance. Think of it this way. The class is here. So this is the math class. And you make objects from the class. You can have multiple objects. And then for all intents and purposes, the class code is copied for each object, and each object is in its own memory address space. But the class is loaded into memory as well. It's got to be loaded into memory. Everything always runs out of memory. It never runs directly off the hard drive. So, if you want to, you can actually make a method that's static and run it right from the class. Methods that are not marked static have the word self, and the code runs from the objects. Methods that are marked as a static method do not have the word self, and they run directly from the class. Now, this is handy because you don't actually have to make a new object to run it. You can just go ahead and put in the name of the class, the name of the method, and whatever arguments are necessary for the parameters, and it will go ahead and perform its function. Static methods are used in classes often when you don't necessarily need to have an individualized object to store data. There's not a lot of data storage going on here, adding two values. It's really more about processing, and if it's just about processing data and not really storing individual data, like data for Bob and data for Sue, there may be no reason to actually individualize the code. In other words, to make it an object instance. Remember that we called the data inside of an object its state. So the state is unique to the object itself. Maybe one customer versus another customer. The state in each object is different, even if it's made from like a customer class. Well, then in that particular case, the actual data is very important, and you would probably want a object instance. If, on the other hand, again, you're just doing basic processing, making static methods is useful. And you can, of course, mix and match. You can have a class that has some static methods and some object methods, or instance methods as they're called. So here's an example. Let's say I make a variable called counter. I'm going to go ahead and flag it as being just a simple variable. This is a person class, and you can see I've got my, in order to make a static field, what I'm going to do is I'm not going to use the word self like I have been doing. I'm going to use the name of the class, person. I'm going to refer to that. Now what I'm going to do is every time somebody makes a new object, I'm going to add 1 to the counter. This class is going to load up as soon as I reference the class. And when it does, it's going to set the initial value of the counter to 0. As soon as I make a new object, it's going to bump that 0 up to 1. If I make another object, up to 2. This will tell me how many person objects I've made. First one will be 1, second one will be 2, and so on. And I can actually count the number of objects being made from one class. Now back in the old days, this was very important because you didn't have automatic memory cleanup. The garbage collection didn't really exist. If you made objects, you were responsible for destroying the objects afterwards. And if you didn't, if you made 5 objects but only destroyed 4 of them, then your program would be leaving behind an object in memory which would take up, well, space in memory. Now, we have all experienced this. We've all experienced this in the form of a computer gets slower and slower and slower as time goes on. You have to reboot it. Why? Because a lot of these little objects are still in memory. They've never been cleaned out. Rebooting it frees up all that memory space, and of course your computer runs better after the fact. Since the older low-level code, like C, C++, runs really fast because it's at a very low level, talking pretty much to the actual machine itself. Kinda. A lot of applications use that low-level code, but along with that comes the responsibility of cleaning up after yourself. And if they don't, you end up with memory leaks. That's why things like Python and .NET, C#.NET, and VB.NET have these built-in garbage collectors, Java 2, to help mitigate that, to stop that kind of thing from happening, so you don't end up with these memory leaks where your computer gets slower and slower and slower over time. So while we don't really need it in Python, in other languages you might see something. And so this example, although not really useful in Python per se, is still kind of an example of how people might use something like this. So every time I make a new object, I bump the counter up by 1. I'll make a little static method that gets the counter count, because I want to encapsulate my little counter. I don't want people working with it directly. I don't want them bumping it up manually to whatever number they feel like. I want to make the counter private and then make my little method public. I'll flag it as being static, and that will tell me, let people get my data. Now I could use a property for this. could use a property for this, but I've chosen not to. I've chosen not to create an attribute. I'm just creating a variable, a private variable, and I'm using a method to access it. I don't have a setter for it. I'm not actually changing it because I don't want them to change it. I only want them to read it. So when I go through and make a new object from the person class, if I get the object count, it'll show that it's been bumped up by 1. If I make a new one, it'll show up it's been bumped up to 2. And if I try to access the counter, I shouldn't actually be able to get to it. Let's try this code out. Oh, let's see. Copy and paste from Word. Where did you go? Line 61. Something in here. Probably one of those smart quotes somewhere. Ah, okay. That was it. It was the ellipse, 3 dots there. Word must have put something wonderful in there. Okay, so this is indeed what I was expecting. Let's see, line 58. Let's comment this out, and we'll run it. Okay, you can see that my counter prints out 1 because that's the first object I've made. Then I make a new object, it prints out 2. Of course, if I ask it to print, I'll see the data inside Bob and Sue. And when I go through here and I try to print out the counter directly, that field is marked as private, and as such, it's not going to let me print out that data. Person has no attribute called counter. However, unfortunately, and Python does some weird stuff. Oh, that's interesting. It didn't actually change it. Now, if I remember right, in earlier versions, it allowed me to change it. It's actually not changing it. It's just ignoring it. Okay, cool. So that's good. At least that's a workaround. Theoretically, you shouldn't mess with this. And what they were relying on earlier was just the honor system. So now they don't give you an error message, but at least they do ignore the value. That's cool. So static methods are handy. You can mix and match them. Typically, if you have a class that has static methods, probably all the methods inside will be static. That is more common than mixing and matching, but certainly you can have some instance methods. You can have some static methods, and of course most classes will have all instance methods and or all static methods, and that's just the common pattern you'll see out there in the industry. Keep in mind, guys, that this is complex stuff, and at first you may not know how to do things. You'll just have to kind of experiment. Also keep in mind that a lot of this knowledge is not going to be relevant to you as beginning programmers as far as developing your own code. but it will be relevant in reading other people's code because that's where most people start learning to program. Going on the internet like you've been doing, searching for answers, being able to read other people's code. So yes, it's true. You probably won't see, you personally won't be using a lot of mixing of static methods and instance methods, but when you hit it, when you find it on the internet, you'll understand what you're looking at. So that's the context I'm going for here. Another thing that you probably won't use a lot of, but you may see out there, is the concept of a private method. And if a private method, the idea is that you use it for some type of internal processing, not outside of the main script. So your main script makes an object, like we've been doing, object person 1, object person 2. But from the main script, you don't access these private methods. They're only used for some time of internal processing. An example might be, let's say I made some validation that checked to see if string data coming in was a numeric value. Well, I might want to go ahead and use that validation technique for both first name and last name. So instead of actually repeating the code, I just might make a validation function and go ahead and have it call the validation function for both first and last name. That way I don't have to repeat my code. Anyway, you can set up a private attribute by going through and using double underscores. You can set up a private method by using double underscores. So here's how I define a private method. And then down here I just go through and call that private method with the double underscores. Now this is private, which means that when I go through and access it, I should not be able to get it. Let's see if that Python's going to do that for me. Okay, so we're going to make this a private method. Nope, I don't want to get it there. I just want to make a private method. So, there's no attribute called that. So now it's hidden. Of course, if I'm getting the data, hiding the ability to read the data is not very useful. But I do have code here that I might want to extract out as a method, and I will hide that. So I'm going to take this, and I'm going to make a new method down here, whose whole job in life is to bump the counter up. So I'm going to call it sat counter. And it's going to bump the counter up for me, and I just call that. Now I want to keep this public so people can read it. But this one I'm going to go ahead and keep private. And again, the reason why you might make a method instead of just doing it in the constructor is so that if you have more than a couple lines of code, you're not cluttering up your constructor with a bunch of statements. Now I don't need this anymore. Instead I use this. Yep. Yeah, every time I call that, it'll bump up the number by 1. And it works the same as before. So this is kind of getting out there. You don't need to worry about static methods. Well, static methods are pretty straightforward, but private methods, and you certainly don't need to worry about counting objects. You don't have to worry too much about going through and accessing the number of objects made and keeping track of all that. That may come in other languages that you study after the Introduction to Programming class. But for right now, just know that it exists, and also it'll be referred to in your reading. We're going to go ahead and try making our own method in the next exercise, but do keep in mind this is just going to be simple. You don't need static, you don't need private or anything fancy like that. We're just going to go ahead and work with creating our own method, and I'll show you what I mean in the next video.